8.6 Inverses of matrices and matrix equations. We're going to be working with the identity matrix, which is notated by I sub n, which is an n by n matrix, so it's going to be a square. And the main diagonal for each entry is a 1, and every other entry is 0. So if we have I sub 2, that means it's a 2 by 2 matrix. 1's on diagonals, 0's elsewhere. If it's I sub 3, it's a 3 by 3 matrix with 1's on the diagonal and 0 elsewhere, which should be familiar from reduced row echelon form. So identity matrices behave like the number 1 in the sense that when you multiply a given matrix A by I, you get out A, or I times B, you get out B. Multiplication by an identity of an appropriate size leaves a matrix unchanged, just like we said. So the inverse of a matrix, we're going to let A be a square n by n matrix. If there exists an n times n matrix A inverse, with the property that A times A inverse or A inverse times A goes to the identity, then it has an inverse. A inverse is the inverse of A. So when you multiply them together, it has to get out the identity. And not every square matrix will have an inverse. For 2 by 2, there's a formula that we'll learn. For bigger matrices, there's a general procedure that you will follow. So to find the inverse of a 2 by 2 matrix, you have matrix A, 2 by 2, A, B, C, D. The inverse, you take 1 over AD minus BC, and that becomes a scalar. It's going to become a number. It's going to become a fraction. And then you're going to multiply it by the matrix D, negative B, negative C, A. So A and D switched places, and C and B became negative. So the AD minus CB, it appears in the rule for calculating the inverse, and it's called the determinant of the matrix. If the determinant is 0, AD minus BC is 0, then there's no inverse of the matrix, okay, because you cannot divide by 0. So we're going to find the inverse of A and verify that A times the inverse is equal to identity of size 2. So we have matrix A, 4, 5, 2, 3. So compared to A, B, C, D, you see that A is 4, B is 5, C is 2, D is 3. We now need to find the inverse matrix. So we take 1 over AD minus BC. This is the formula. D negative B negative C A. So we go 1 over 4 times 3 minus 5 times 2. We're going to multiply that by 3, negative 5, negative 2, 4. So 4 times 3 is 12 minus 10 goes to 2. So A inverse, 1/2 times 3, negative 5, negative 2, 4. That is the scalar. It is now multiplying everything. So A inverse is 3/2, negative 5/2, negative 1, 2. We now want to check that A times A inverse gives us our identity of size 2. So we're going to take A, our original matrix, 4, 5, 2, 3, multiply it by A inverse, 3 halves, negative 5 half, negative 1, 2. We know it's going to work because it's a 2 by 2 times a 2 by 2, and our outcome's going to be a 2 by 2 as well. So we get 4 times 3 halves, which goes to 6, plus 5 times negative 1, that's negative 5. 4 times negative 5 halves, that goes to negative 10. 5 times 2 plus 10. Second row, 2, 3 times first column goes to 3 plus negative 3. 2 times negative 5 halves, that goes to negative 5 plus 6. So we get out 6 minus 5, that is 1. Negative 10 plus 10 is 0. 3 plus negative 3 is 0. Negative 5 plus 6 is 1. This is the inverse matrix, size 2. So it did, in fact, work. Inverses for larger matrices. So this is for n by n's that are 3 by 3 or larger. We're not going to work with anything larger than a 3 by 3. So we first construct the n by 2n matrix. It has the entries of A on the left and the identity matrix size n on the right. So here's an example. We have our given 3 by 3 matrix on the left, and then we put a dashed line to separate it, and we have our identity matrix on the right. So we're going to use elementary row operations on this larger matrix to change the left side into an identity. So we're going to use our row changing methods that we've used previously to get 1, 1, 1, and the rest zeros on the left, and that therefore will change the right side. And it must go down to reduce row echelon form. Okay? The right side is therefore transformed automatically into A inverse. So we have matrix A given, and we want to find A inverse. So we're going to set up our n by 2n. And on the right side goes our inverse matrix, and we need to get the left side to look like the right currently. So we have our leading 1, so we need to get zeros underneath of it. I'm going to take row 2 minus 2 row 1. And so on the right side, we're going to have 0 minus 2 times 1. So that goes to a negative 2. 1 stays 0. And we got to change row 3. I'm going to take row 3 plus 3 row 1. So that's going to go to 0. This is as well 15 minus 12 is 3. And then 0 plus 3 is 3, 0, 1. So we now have almost half of our left side complete. We got 1, 0, 0, 1, 0. Now let's change this 3 to 1. I'm going to take 1/3 of row 3. And it goes 0, 0, 1, 1, 0, 1/3. So yes, we will have fractions. Do not be scared of the fractions. We now need to get the 2 and the -4 to become zeros. So row 1 plus 4 row 3. So we get 1, -2, 0, 5, 0, 4/3. We can also at the same time do row 2 minus 2 row 2. Goes to 0, 1, 0, -4, 1, -2/3. And row 3 stays the same. Last thing we need to change is this -2. By using row 2, we can get rid of that. So we're going to get row 1 plus 2 row 2 to get our new and final row 1. 1, 0, 0. See, that's going to go to -3, 2, 0. And then everything else stays the same because we have our left side in reduced row echelon form. So the last step is we just take the right side out and make our inverse matrix. It is a 3 by 3, -3, 2, 0, -4, 1, -2/3, 1, 0, 1/3. So let's find the matrix for A. I've already set it up into my n by 2n with the identity matrix on the right. Let's get a 1 in the upper left-hand corner, but the row right underneath it has a 1. So let's switch row 1 and row 2. So 1, 2, 7, 0, 1, 0. 2, -3, -7, 1, 0, 0. And the last row stays the same, 1, 1, 4, 0, 0, 1. So if we have our leading entry 1, we need to get zeros at the 2 and the 1 spot. So we are going to take row 2 minus 2 row 1. At the same time, row 3 minus row 1. So row 1 is not changing at the moment. Row 2 becomes 0, 1, 2, -2, 1. Yeah, those were wrong numbers. All right, let's go 0, -7, -21, 1, -2, 0. That looks much better. And bottom row goes to 0, -1, -3, 0, -1, 1. We now need a 0 in our middle column. I'm sorry, a 1 in our middle column. I have a -1 here, so let's combine 2. Let's go negative row 3 and then switch it with row 2. So for the first time, I'm combining 2 of these steps in 1. So now I need to get rid of my -7. To do so, I'm going to take row 3 plus 7 row 2. So our new row is going to go 0, 0, 0, 1, 5, -7. So if we look at our matrix now, we have an entire row of zeros. But then I have this 3 right here. I can't get rid of that 3 or this 7. It's not possible. So when we have a row of zeros, on the left, the original matrix does not have an inverse. So this is an example of a matrix that has no inverse. So matrix equations can be made taking our system and making a matrix of our coefficients, and we're going to times an x, y, z, or just an x, y, or whatever variables we have, and it's going to equal our answer. So instead of putting it into an augmented matrix, we can make matrix equations. Because you're taking 1 times x, -2 times y, -3 times the z, and that becomes your first entry. It's just a different way to write it. So if we're given a matrix A, and a matrix X, and a matrix B, this matrix equation can be written as AX equals B. The matrix A is called the coefficient matrix, and we solve the matrix equation by multiplying each side by the inverse of A. So you would have to go through the work and find the inverse of A, and then multiplying B by it. We're going to do this with a 2 by 2 matrix. So we have our system. Let's make our matrix A, which is our coefficient matrix, 2, -5, 3, -6. Our X matrix, we are just using X and Y. And our B matrix, which is our answer matrix, 15, 36. So to solve for x, solve for matrix x, we need the inverse of A. So because it's a 2 by 2, we can use the determinant from before. 1 over A times D, so 2 times -6, -12, minus BC, -15, times the matrix D, -B, so 5, -C, A. So finding the inverse of A, I'm going to take 1/3 times this matrix. So we get -2, 5/3, -1, 2/3. So now to solve for x, we take the inverse matrix times B. And that will work because it's a 2 by 1 times a 2 by, a 2 by 2 times a 2 by 1. So we're going to take -2, 5/3, -1/3, 2/3 times 15 and 36. So that goes to -2 times 15, which is -30, plus 5/3 times 36. 5/3 times 36. That goes to 12, so it's plus 60. And then -1 times 15. And then we have 2/3 times 36. Goes to plus 24. So matrix X is 30 and 9. But please remember that matrix X is XY. So we know X is 30 and Y is 9.